Hi, thank you for being here. I'm Loris, as was just said. We're here to talk together about how to productionize your ML code seamlessly. As was quickly mentioned, I work for Yelp, and this is not working. Nice. No. Neat. Yes, I'm over here. Yes, awesome. Yelp is all about connecting people with great local businesses. That's the core of our mission. You probably have used the site, especially here in the UK. If you type things around Edinburgh, you might end up looking for this. That's what you will do, find restaurants. Your local plumber, a moving company to help you move your code seamlessly into production, anything that is needed. Just to give you an idea of the scale at which Yelp work, we have a lot of reviews, a very high number of unique visitors per month, quite a big team, lots of service, lots of code, and which means a lot of people working on data. So we have learned quite some ideas on how to make our life a bit easier, putting the models into production. What's on the menu for today? Well, it's kind of like presenting, what does that mean? Like putting a model into production. That's probably the least self-explanatory sentence ever made. And then I will kind of give some tips and tricks to actually make your life easier. Before we actually go into the deep of the subject, I just want to kind of just take a moment so we all kind of agree on what I'm talking about and what's kind of all of this fits into. I think every ML project in Python are started in a notebook. If it didn't, probably something weird was happening. And this notebook you started writing this notebook because someone gave you a data set and questions and you needed to answer it. And in a way, that's kind of the core of it. You don't do machine learning just to do machine learning. You're trying to predict a desirable behavior. You're trying to recommend. You're trying to detect. You're doing something. You have an objective when you start doing machine learning, and your notebook does something. Whether your notebook is simple, your features are already all nice, and you just apply a few transformations, you train your model, do some feature analysis, and maybe check that your model actually didn't train in a too crazy a manner, or you end up with pages and pages of SQL queries that perform feature extractions, and you have a complicated model, and you have everything mixed up. Hell, it doesn't really matter in a way, because what brought you to the stage where you think you can bring this to production is, at the end, you had a result. You had something that made you think, yep, I think I can do it. There's a problem, I can crack it. But now you cracked it in a way once, and you want to crack it on a regular manner, and you want to be able to generate, train regularly, make sure that every day your model is not too bad, and then your model produces something that you want to use. And you need to deliver this something, whether it be predictions, trend, to the final users. And finally, kind of, hey, I wanted to do something right at the beginning. Now that everything is done, is it still happening? So right now, you're at the first step. And I will show this probably overshown schematics from hidden technical depth in machine learning systems that Google presented at NIPS 3 years ago. And right now, you're here, this small, very black circle, which I put in red because it's even really hard to see. And you need to interface yourself with all the rest of what your live systems are. So now, in a way, what does running an ML model in production involve? Well, it's kind of putting any other piece of code in production in a way. There is not so much difference. You're going to interface yourself with the surrounding infrastructure, and the goal is to run from something that runs under your benevolent supervision, skipping the few cells which actually don't run correctly in your notebook, to something that runs every day, tells you when it's wrong perfectly, and probably even after you stopped looking at it. Great. So as you might start to guess, I'm not going to talk too much about tooling. That's really not the point. This conference was full of great people showing you awesome tools to do everything. I'm more going to focus on actually what does it mean? Like, what are the things? How you think about decomposing the problem, putting things into production, into a series of steps and questions that you should be asking yourself and answering to arrive to it. Probably the answer to many of these questions is use Airflow, but that's another topic. Great. So for sake of argument, and as I'm talking generality, let's just agree all together on a simplified view of what the pipeline is. So first you have data sources. This can be many, many different things. You perform some sampling on it, maybe or not. I don't know. You extract some features that you have defined. Probably that's your notebook told you that this set of features was working really well. I should definitely use that. You train your model. You evaluate that everything went well. You have a model. Rinse and repeat for production, and then you're loading this prediction you have obtained into your product. Kind of fair. Why is this useful? Well, actually, probably your notebook performs exactly all of this operation, but what this tells you is which piece should go together, which piece should be one function or one Python module, and be tested together because it makes sense together. Right tests? Cool. Let's kind of focus on specific parts of this pipeline. The first part I want to check on is the data sources, even though I'm not going to talk too much about it. It can be S3 logs, anything, Redshift, MySQL, Postgres, something I didn't think about when I was writing these slides. It's likely to be changing regularly. You have new data coming in on a regular basis. And how your system ingests the data is just admitted for the purpose of this talk. I won't go into detail. You might also have noticed, especially if you have already worked with models before, that this looks a lot like a kind of specific type of training, which is everything happens offline. You have all the data you need at all time. You have offline training, offline predictions. Things with online prediction or online training would not be that different. It's mostly constrained on the data sources. I will stay in the simple case. Cool. So first thing first. You need to update your model on a regular basis. And now the question is, on a regular basis? What does that mean? So that's up to you in a way. It's how often does your data change enough that your model needs to be changed too. The other point is what happens when things go wrong? How do you rerun your pipeline? What happens if your data, some data is missing? Do you pick old data and you fill it in, maybe? Maybe it's not worth it, you could just reuse an old model or any other strategy you can think about. The other one is the scale, which is how many prediction or what size is my input training? How long does this thing should take? This is what allows you to think about how you should dimension the infrastructure that all of this is running on. We're talking about model, we're talking about failure. Very often when people write code and they think failure, they think, oh, I got a trace back from Python. But it's not exactly the only way a model training can be failed. And that's why you have an evaluation step that I really want to dig a bit deeper into. And some questions you could be asking yourself is, does the evaluation metric I'm using actually reflect the problem I'm trying to solve? And I think we all use things like log loss or area under ROC curve or other kinds of problem. And the question, and I want to tie it back to what I was saying, is does it solve your problem? Maybe, maybe not. Think about it. Some functions have very good mathematical property, but they might not represent what you're actually trying to move. Last part, when evaluating your model, kind of think about which feature I used, because this is the point when you can look at if there is feedback loop. Your model doesn't just run on its own now, it's generating prediction, which means it's affecting probably how your data is generated. And if in time you see things like, oh, your model just relies on one feature, maybe this one feature is actually your model just repredicting what it was predicting before. So beware, this is a time when you could say, actually this training is failed because the model doesn't behave the way it should be. Now let's go to the prediction side of the schema. Questions are exactly the same. What happens when things fail? How often does this happen? And how many predictions should I be generated every day? And the last thing is, which is a bit savory, is how do predictions are used and how are they used in your product? And that's what I would want to kind of push into. Right now, I've said nothing about in which order things should be made. I just said that's the whole problem, deal with it. Actually, is this probably what you might want to start with? How are the predictions used in your product? Because you have predictions, you had them once. And so if you can already start using these just to test, it means you can see if you're actually successful or not. And that's probably the last thing, which is how are you measuring success? How do you say, I did my job, it's right, project over, thank you very much. The first thing is you need to track the metric, business metric that you're trying to move. You need to go back to your original problem and be sure that you can actually track your model is doing something. And you need to test it, confront it to reality. And you might not get it right from the get-go, in which case you should test new versions against old versions, against probably status quo. And the last part is measuring success is always very easy. You could say, yeah, I'm going to do this, and it's, well, story time. I work for a team called Biz Growth, and our main objective is to get people to create a special kind of account which is tied to a business so people can manage it. One of the good ways we found to do that would be to show people a little pop-up, but if we show it to everyone, it's kind of not really working. So we thought, hey, we're going to start predicting which people would be actually likely to be owners, and so then they would create the account, this special business account, and we show them the pop-up, the algorithm design, if we draw the pop-up or not, and then we move forward. And so that's what we did. We built the whole model. We trained to predict if someone was potentially an owner or not. We showed them the pop-up, and all the time, like 94% of the time, they would create the account immediately afterward. It was great. We had great numbers because we were measuring our success by they clicked the little button, they clicked on the pop-up we were showing them, and then they were creating the account. But actually, the number of total big number of accounts created didn't go up at all. It's sad, so we looked again, and actually what our model was doing is it was predicting what would happen, whether we did something about it or not. So we kind of checked that. We created all that set of people that we could have shown a little pop-up to, and we didn't, just to test that our model was behaving correctly. And they were creating almost as much account as the people were showing them to, but a bit less. So we're still happy. It was still working, still worth investing in it. Still, it's really hard to get that wrong. It's really worth spending some time thinking this through. I've already kind of synced smoothly into a transition with stories. Tips and tricks. Sorry. So start with general advice. You might feel like this is something you might have seen into putting your service into production. Yeah, good reason for, as I was saying, ML code is code. Use containers, Docker, Kubernetes, whatever you want. Containers are great. Virtual environment, even more awesome. Try to spend some time persisting your work, whether with version control, with persist everything you do, the logs, everything you want. You might want to be able to look back at it in 2 weeks, a month, maybe not a year. You might want to add a TTL to that. The last 2 points are maybe a bit less common. It's use the production technology from the get-go. Story time again, we had data scientists. They made a lot of effort to try to figure out how search and lots of pages were related. It was all done with Redshift. It was working in Redshift because Redshift didn't have all the data set. And then I had to write 1,000 lines of SQL query into Spark. This took 3 months. This is a loss of time for everyone. Spark is probably even easier to use than SQL. If the production technology are widely available, even if it's an extra cost, it's actually saving development time most of the time. And the last part is if you're working in a company and you're doing ML models, it's probably already a lot of things happening. You probably already have a software that runs software in a regular basis. Just don't reinvent the wheel. Cool. Now let's dig into several parts. Schema was not that great, because it might have led you to believe that these two things were different. They are not. You should not have 2 pieces of code for feature extraction. You should, apart from label, fair suitcase, this should be unit tested. You can use things like hypothesis to generate a bunch of random data to test all of your edge cases. And don't write SQL. This is making people's life hard. Write everything as code that can be tested, unit tested, mostly. Now, on the training, I'm going back to evaluation again. Actually, I might have said this in previous part, but just to put emphasis on it, perform feature important analysis, keep it somewhere so you can know when your model actually goes out of way. If you had done any piece of code to just check that your data set was right, or that anything you had done basically in your research phase that gave you confidence that your model was good, you should still keep it, implement it, and run it regularly. This is what going to make sure that the assumption you've made with the data set stay true in time. Also, classics have a small sanity check test suite with just a small set of data, just to be sure everything is running while you're developing, not breaking production with a push. This is bad. Now to all the things advice. First one is log all the things. You want to know what's happened with your pipeline. It's not running under your supervision. Get it to log everything. Like the sampling, you had like some ideas on how the class was selected, what are the things, log it. Feature extraction, log everything that happens, how many features were extracted. Maybe some small statistics about the features. You have a problem, you can just look at your log, you don't have to recalculate everything. Model training, log everything that happens. Evaluation, we just talked about it. Log feature importance, these kind of things. Log. And in your product log, when you're actually using your prediction, what usage is made of it? Everything, every time you're actually doing something, you want logs, you want to know about it. This is how you measure things. Second one is version all the things. And yeah, that's how you keep track of change. Feature extraction, you might add, remove features, write different functions, maybe with different names. So also, if you want to persist the features that are extracted before the model training, in case the model training fails, same thing, if you have a file which is written with the days the features were extracted and which version of your feature extraction was actually performed, it's much easier to go back and understand what happened. If your model has a version, it can be several, like just a git commit, it could be semantic versioning, it can be both. It's great. You want to change go from logistic regression to XGBoost, bump the version, you're changing the hyperparameters, bump the version. There is nothing more frustrating than to know that there was a model that was generated and you can't remember how or know how it was done. Plus, if you have a version and you have login, it's really, really easy to know which prediction generated by what, especially when they are used, which facilitates evaluating success and doing experiments. This is basic data traceability. So now with all of this, we can think of maybe some general ideas on how to monitor the pipeline as a whole. Keeping track of the number of predictions generated is a good way, and prediction used too. So it tells you which part of your things could be broken if it's not things. Keeping track of timings to be able to see which part of your code starts to become slower and why. That's also very important, especially if it has been running for 1 year, no problem, and slowly crept up. It's very different from it was running really well, and suddenly the amount of time it takes doubles. Alerts on errors in your pipeline code. It can go as simply as send me an email at this email address if you don't have an alerting system set up. Otherwise, set one. It's really practical. And kind of as a last line of defense, if anything else fails, alert on the metric you were trying to move. You had a project at the beginning, and this all ML things, this all production, all this effort don't live in void. They serve a purpose. So just alert when the purpose is not accomplished. And maybe everything else looks fine, but if this doesn't, maybe there is a problem. It's worth looking into it. Last but not least, write runbooks. How is this system supposed to work? And initially, how you thought about it. And then every time something that you didn't think about actually happens, because reality is reality, add it there so you can remember how you solve the problems and how to handle failures easily, especially when it breaks at 4 in the morning. So now, just if it was a bit boring and you fell asleep, I'm really sorry. But if you just need to remember 3 things, it would be this. Design for change. It's really the main difference when you do systems in production. The code is probably going to outlive you in the company sometimes. Just change slightly the mindset about it. And as I was saying, machine learning code is code. There were 30 good years of best practices in writing software engineering, and use it. It's not different. It seems different, but it's not. All the good ideas are mostly there. The last part is verify any assumption you make, because again, things change and evolve, and so you need to be sure that any assumption you've made are still verified with your systems. We're hiring. If any of this was interesting for you and you want to join us at Yelp, we have offices in Hamburg, London, San Francisco. We had a stand with this end of advertisement, I thank you all very much, and I will be taking any questions.
Thank you for this great talk. Where are questions? Let's begin here.
Thank you for a talk. So you say it was not a talk about tooling, but do you still have any advice? Because some part of software engineering still apply to data science, but we've got some specific problems like data unit testing or input validations, and also versioning everything. You can just put all your data on Git, so that's also a problem.
It is. My advice is we use S3 quite extensively because storage is actually really, really cheap, and just throwing everything at S3 and figuring out later is actually working. It sounds really bad, but it works.
But as you keep this model was learned on this data, do you have just keep IDs everywhere, or do you have any way of?
I'm not sure I understand the question. Could you?
When you got this model and it was learned on this extract of data, and how would you keep track of that? That this model produces this result from this data and this feature extraction?
Right now we have semantic versioning. So every time we change something to a model which is in production, we bump this version. All the models, when they are written as a file name that contains the version that was generated with, and sometimes a git commit of the version that was running when this was done. And most of the time, combining the two, you can actually know what happened and just reset your repo to an earlier version if you need to reload it or remember what was done.
Okay. Thank you very much.
Thanks for the talk. Any comments about regression testing after you deploy models? So this is something which I have faced in teams that I've worked for, because regression testing is a part of software development, and machine learning deployments are kind of non-traditional because when models change, outputs of non-inputs change, and then QA analysts go, everything's changed. Yeah. So how do you handle that?
I don't really have a great answer, but I would say, if I can go back here, if you look regularly at the metrics you're trying to move and what your model is supposed to do, you will know when there is a regression because the numbers you're trying to grow are not going to move in the directions they used to. So it's not like regression in the same sense as the code. It's more you look at regression in the patterns in the things. I would admit this is more problematic than with code because it can be other reasons like, hey, today is actually, all the metrics are going down, what's happening, it's horrible. Oh yeah, today is a holiday, so actually everything's fine. So, that's super reactive, right? Like that's post-cloud. So once you deploy it, then you see these metrics move. But for example, you messed up something which was bugging the code. Oh, well. Predictions should have been one way and they aren't. So we catch those that ideally would catch using some sort of regression test. You have something particular. Yeah. So here what we're doing right now is we're never deploying a new model immediately. We are doing progressive releasing. So you have the current model version, which is big. We release the new version for a small part of the traffic. And we look, everything is fine before actually switching it. So that's how we solved it. It works.
Hi, thank you for the interesting talk. One comment and a question. On the measuring things, there's a great blog entry by Uber that talks about how they do it with actually machine learning the metrics. On a question on the log everything kind of approach, that goes very much against the way, for example, Jupyter Notebooks makes us write. How do you square that, and what's your advice on that?
Yeah, I might have gone a bit about it. I'm not really a fan of, there are a bunch of things that allow you to productionize Jupyter Notebook directly. I think there are several problems with that, which goes with code quality, because structure in Jupyter Notebook is very linear and code isn't. It's hard. write tests I would be very interested in seeing tests, actual real nice tests that are written in Jupyter Notebook. Maybe it exists, I've not seen it. So it's completely a different beast in a certain sense. You're going to check in your code real, and it's going to become not an experimental thing anymore. It's going to be a Git repo that runs, is deployed. Maybe there is a way to bridge that gap. At the same time, I'm not sure it's a good idea. Like Jupyter Notebook is really, really good at doing what it does and checking in code so it doesn't change too much, and it's not that easy to change. And you can track all of the change and do everything is what you need for production. Does that answer the question?
So the question is, you don't actually use Jupyter Notebooks?
So we use Jupyter Notebooks for everything that happens before we put it in production, and then you start copy-pasting the code from Jupyter Notebook into an actual repository. You start writing tests, you start going back to data scientists, like, so you did these two things here, like the two intervals are not exactly the same. You ask questions to try to improve, and you start doing code reviews. And you make sure everything works in a regular fashion. So it's really two separate workflows.
Thank you. The talk was brilliant and I think great advice for people who are developing the models. Do you have any advice for application software engineers who need to integrate a model into a product or a feature, or perhaps advice around collaboration between a data scientist coming up with a model and a software engineer implementing it?
Yeah, so I have some advice in a way, and it's more organizational. And what I think is important is everyone kind of is on the same page. That the data scientists are using roughly the same tools you're going to use in production, and not have their own little word which works, but actually you're never able to translate it. And the other part is if you're a data scientist, you spend 4 months working on the model, and you have an engineer, like that would be me, that comes and kind of take it and does a lot of things with it and put it in production. I think it's very important to keep that person in the loop, because you have a sentiment of ownership with this. And this is what we're doing. So keeping people in the loop and being sure that things stay within the things. That was a very vague answer to begin with. I hope this was understandable.
Okay, 2 more questions, I think.
Thanks. You mentioned S3. Do you also use, like, for example, S3 to trigger, let's say, the modules are in a Lambda or something? Do you use serverless for that, or?
So I don't. I know some people are playing with it. I have no experience in the subject.
Thanks. One last question, if anyone? No? Okay, then directly here. Sorry.
So it may be a little bit off topic because you said you won't be talking about tools itself, but can you guide us what to look for and just pop out some names to check out?
Yes, I have a particular liking for Spark, to be honest, because it handles datasets of all sizes. It's very easy to run locally. You can write unit tests with it and just pretend that your test instance is gigantic, and actually it's just, I'm using 1 CPU and everything works-ish. So yeah, I have had lots of algorithm models. XGBoost are compatible with Spark. I would always say kind of have two guns, one which is a good old tool which is well tested, and this Spark is kind of old and not trendy anymore, which means it's stable and actually works in production. And try out the new things to see if you can leverage them and what are the problems with them.
Okay. Thank you.
So thank you very much again.
Thanks a lot.